Hi, in this video we are going to talk about the particles that make up the atom. Alright, so there are three subatomic particles: protons, neutrons, and electrons. The protons are located inside the nucleus of the atom. They have a charge of +1, and they have an approximate mass of 1 AMU, and an AMU is short for atomic mass unit. Neutrons are found also in the nucleus. They have a charge of 0, so they're neutral. And they also have a mass of about 1 AMU. And then electrons are located somewhere outside of the nucleus. They have a charge of -1, and they have, for simplicity's sake, we say that electrons have a mass of 0 AMUs. That's not really true. The electron does have mass. It is just so small compared to the proton and the neutron that we essentially ignore it. So in our chart here, it says that the electrons exist in orbitals. Those are somewhere outside of the nucleus of the atom. So if you take a look to the picture, you can see that inside of the nucleus, we have protons, which are blue, and neutrons, which are pink. And then somewhere outside of that nucleus, and we would refer to this again as a cloud of electrons, that is where you will find the electron. We will spend quite a bit of time a little bit later in this chapter talking specifically about where those electrons are. So when we're talking about a specific atom, it is useful to have a representation so that we can count or basically see easily what atom we're talking about, or what element we're talking about, and what the atomic number is and what the mass number is. So here, what we have, first thing I'll show you here is we have our atomic symbol, and we've already talked about this, right? So we know that each element on the periodic table is represented by a symbol. Right? So for example, carbon is a capital C, neon is a capital N, lowercase e. And that just makes it a little bit easier for us in representing or telling people what specific element we're talking about. The other two pieces of information that we're going to be talking about here are the mass number and the atomic number. So the mass number, remember that for the mass of the atom, that primarily the particles that contribute to the mass are going to be the protons and the neutrons. So remember from the previous slide, we said that protons and neutrons both have a mass of about 1 AMU, and we said that the electrons were about 0 AMUs. And so all of the mass of the atom primarily is going to come from the protons and the neutrons. So if we add up the number of protons to the number of neutrons, that will give us the mass number for that particular atom. The other important piece of information is the atomic number, and that is the number of protons. For this, I want you to be thinking that this atomic number, or the number of protons, is going to help us identify what that particular atom, or the identity of that particular atom. So if I tell you that you have an atom that has 2 protons, I know that atom is helium, because helium, that number right above the symbol, that is the atomic number. Right there. Right, so each element has its own unique atomic number. Hydrogen is number 1, helium's 2. If I wanted to know about zinc, right, if I told you that an element has 30 protons, you would know that that was zinc. Okay, so for the picture down at the bottom, we are dealing with a specific atom here. That atom is carbon, and I can tell that from the symbol. And I know that carbon, because I have been given the mass number, right, or sorry, the atomic number, that carbon has 6 protons. We are currently talking about neutral atoms, and so what that means is that the number of protons is going to be equal to the number of electrons. So you should definitely write that down, right? A neutral atom, the number of protons is going to equal the number of electrons. Now the last bit of information that we have here is for the number of neutrons. Now this is going to come from the mass number. In order for us to figure out how many neutrons we have, we are going to subtract, remember again, that the mass number is the number of protons and neutrons. So, if I know the mass number and I know the number of protons, the number of neutrons is going to be equal to that mass number minus the number of protons. So here that would be 12 minus 6 gives us 6 neutrons. Alright, so we're going to practice figuring out the nuclear symbol, the element, the atomic number, mass number, number of protons, number of neutrons, and number of electrons. So in this example, we are going to have, I'm going to give you our nuclear symbol. Oops, I'm not sure what's going on there. Okay, so that is a 39 as your superscript and a 19 as your subscript. Now if you take a look at your periodic table, this element is potassium. And again, I apologize for my handwriting, as potassium, or has the symbol K. Now the atomic number, remember that the atomic number is the identity of your element. That is always going to be given to you here as a superscript. And so my atomic number here is 19. And if you double check your periodic table, you will see that as the number above the symbol on the periodic table. Mass number is given to you as a superscript on the left hand side of the symbol, and so my mass number is going to be 39. Now remember that atomic number and number of protons is the same. Again, that gives that atom its identity, that's 19. If I wanted to find the number of neutrons, remember that the mass number is the protons plus those neutrons. So if I wanted to find just the number of neutrons, then I'm going to take this and I'm going to isolate just the neutron. Right, so I know that I have 39 neutrons and protons, and if I subtract out the number of my protons, that will give me the number of neutrons, which is 20. And we are talking about a neutral atom here, so the number of electrons and protons is going to be the same, so that is going to be 19.